Okay, hello everybody. Welcome to today's interest session. This is Introduction to Cybersecurity as a Career and a Technical Workshop. My name is Dr. Nizik. I'm the director of something called the ETIC, or the Entrepreneurship and Technology Innovation Center at New York Tech. Basically, we're a combination of a business incubator for our students, a prototyping center for new technologies, and a student engagement center for programs like interests today, this session and this program, and also things like our robotics project called Ursula that you can participate in as well. So the way these sessions work is we're going to break it into two sessions. The first kind of session today, it's a total 45-minute session. The first session will go over some introduction to cybersecurity as a career. The second will be some technical discussions and a brief demonstration of some of the tools we use in cyber to detect, prevent, mitigate, different threats from different actors. Okay, essentially. All right, so without further ado, I will begin the session. And those of you with regards to the ETIC, if you have any questions about what we do at the ETIC, you can always visit us at nyit.edu/ETIC. And if you do not or have interest in starting going, we can help you with that too. But also, if you just want to join as a student, get the latest alerts or things that we have going on, the YouTube channel, we're going to send out a link to, and you can join that. You can kind of subscribe to that and all. Everything. So that's going to all kind of launch at the same time. We're just producing the videos now. So feel free to visit, take a look at some of the news pieces we had. So welcome to Introduction to Cybersecurity as a Career and a Technical Workshop. The reason we introduce these interest sessions to you is to give you kind of an enhancement or an addendum to some of the stuff you learn, on a regular basis in our classroom sessions. Sometimes, we don't have the luxury of being able to expose you to certain things that you would be exposed to in the field as much as we'd like. So these are a little, kind of supplemental sessions that you can participate in, something like today, but then also review, again, on the YouTube channel when you want to kind of go back and take a look at something. These interest sessions are geared to introduce you to career opportunities in certain respects to some of the tech that we teach, but also to introduce you to some of the tech that is very proprietary and may not be introduced in a classroom setting. Okay, so to talk about cybersecurity as a career, cybersecurity has been around for a long time, just as different things like InfoSec, information security. So cybersecurity is the new term over the past, X years, where it's been its own sector, right? For a while, it was always just part of computer science and part of IT, information technology. But now it's like its own sector. Like there's specialists that are becoming available just to secure computer networks, just to secure information systems, just to secure databases. And that's why we talk about this specifically as a career. A lot of students make is that they say, I'm going to go into cybersecurity, but they don't really understand that they need a background in information technology, right? Because they're treating it as a separate, really, sector. Doesn't mean you can't really do that sector without having the other piece too, right? So you really need a computer science, information systems, information technology background at a minimum, educational background, even though hands-on. But the cybersecurity piece won't make total sense unless you really have that experience. So this is kind of an introduction to kind of talk to you about the industry, but also to explain some of the things that you need to focus on to make sure that you're considered viable as a candidate for those jobs in those industries. So if you look here, you'll see this is a simple Indeed search, and you'll see 22,000 jobs available for cybersecurity, right? There's all kinds of different jobs available. You can be a cybersecurity reviewer, as they mentioned here. You can be a director of cybersecurity architecture, right? We're going to go over all the different terms or the different job titles that are available in cyber today that you can look at and what each one kind of entails. But just to give you an idea, it's one of the rarer things found, but one of the most in demand, right? So it doesn't mean that there's so many jobs out there that you're going to get the job. You really have to know what you're talking about in trying to find skilled personnel with the jobs that are available. That's what the crisis is right now. And that's why, we run programs like we do at New York Tech for our concentration programs and our cybersecurity master's programs to give people that edge when they're going for these jobs. So one of the things that you'll kind of notice in any job that you look for is that you'll see like this really, really broad spectrum of jobs, right? And that's because everything involves security today. And that's because the government has now implemented a number of different compliance requirements that organizations must maintain as far as their data, as far as privacy, protecting data. And there's fines associated with those. So to give you an idea of why there's such a boom, right? There's mandatory requirements for healthcare and finance and all these different industry sectors to secure the data that they're storing for their customers. If they don't show that they're doing at least the minimum of what they're supposed to be doing, they could become personally liable for the damages. So there's a big push to get qualified people to make sure that those efforts are in place. So the government's requiring, just to give you an idea of why these jobs are available, the government's requiring organizations to show due diligence on their part to secure data. Otherwise, they're personally liable. If they don't show it, not only are they personally liable, but they're also fined really large amounts of money. So they need a team of people really to make sure that they're meeting these requirements and can show it in documentation that they do. So there's all kinds of jobs. If you're not a coder and you're not a network expert and you're not an operating system expert, there's still jobs in cyber because the auditors need to document their defense and document their procedures and policies and things like that. So even having a base level of understanding of cyber and what it entails, even somebody with an accounting or an auditing background or interests can get a job in cybersecurity in the sector because that's what's needed because of this driving factor. All right, so that kind of lays out the groundwork why these jobs are available and why there's so many unique and interesting different types of jobs out there. So we call it the workforce gap, and we have this huge gap between students getting trained formally in programs like ours and actual jobs that are open, and that's where this gap falls. Challenge right now is that even students coming out of school with a degree that don't actually get involved in some sort of a hands-on application or program, they're having, they need to get that experience to show that they can do the job, which is really where that gap is happening, right? So you have a number of different programs, even including today, like this one, to kind of introduce you to all these real world type efforts that you need to put in place. Okay, so let's look at the landscape of different cybersecurity components here, right? So we actually have real world, popular, very common things that we should all have heard about it somewhere on the radio or TV or whatever. All these different companies, these organizations were attacked and breached, right? So you broke through the barriers, we'll just call them barriers for now without getting too technical, and wound up acquiring sensitive data, right? Data that can be turned into monetary values. They do this with methods, right? They have different methods, and you should have heard of some of these because these are the things that make the news too. When a new type of virus, a new type of worm, a new type of spyware, malware, a new type of device that has software on it, these are programmers, right? These are programmers like yourselves. If you're going through the computer science program or information systems program, you've taken programming. They're programmers like yourself that design software that will basically open up various different ports or really just create different vulnerabilities on a system once they're run. Because local workstation firewalls like, Windows Defender and Norton and McAfee and all the big companies that host those services have become very strong and very powerful and very good. The number one way of attackers to get their software to run on a machine is through social engineering. Social engineering is when you get an email, right? We call it phishing, right? So when you get an email that says, hey, do you want to win $1 million? Click here. And you say, sure, I do. And you click. When you click that, it's a scripting language, right? It's usually, some sort of a server-based scripting language that will run the local code on your machine once you click it. That's really all they have to do based on the quality of coding. But really, depending on what system you have in place, what firewalls you have in place, and what network security you have in place, and what workstation you have in place, what workstation security you have in place, if the user simply gets an email and clicks on that link or even voluntarily goes to a website because they think it's Bank of New York or they think it's Chase Manhattan or something like that, once that link is run, once the scripting code is run, there's really no, stopping what that code is going to do. And I'm speaking in general terms. There's other things you can do to secure that, but that's what the career perspective is. What can I do on my local machines? What can I do on my servers? What can I do on my network to stop the human factor, the human element from making these mistakes that allow everybody in? It's like having a kingdom and a castle and a moat and a gate, and you got trained guards and all that, and you don't train the people, the civilians walking around inside, and they just open a window because it's cold out, right? It's because it's warm inside, they want to let cold air in. You haven't trained them to say opening that window is going to let the bad guys in, and that's really what it is. You have basically put together this fortress as a security expert, and you haven't trained your internal civilians, your people, your workers to basically not let in the bad guy. And that's what happens with phishing. They send an email out and say, oh, I'd like to see that. I haven't read that book yet. Let me read that book. As soon as you click it, it's not just bringing up the book. It might not bring up the book at all. It might bring up an error page, but it still ran the code on your system. That's what's happening to all these companies and all these particular pieces of software. They're written to damage machines and give access from the outside in, but they're run from the actual individuals who work in the organizations. That's what social engineering is, that's what phishing is, and that's what the scripting languages do for programmers. They allow an inside user to run their code unbeknownst to them and unknowingly, and they let the bad guys in. All right, so we said cyber's been around for a long time, but even more so, what are we really after? We're after, binary code. We're actually after the zeros and ones, because we can take those together. They can take those as a whole, string them together in groups of 8, and we can get the characters, and we can look at that. If it's unencrypted data, which much data is, once it's taken from the hard drives, data in transit, much of it is encrypted, but data that's on the hard drives, much of it is just open and plain text. So once we get those zeros and ones, we can basically turn into valuable information that we could possibly benefit from and more importantly, profit from. Unfortunately, I know and have worked on some of this equipment in my lifetime. I know I'm dating myself, but basically we came a long way from Alan Turing in 1936 with his initial paper on binary, which was just a theory, but he built the first computer to actually wind up cracking that code. Back in World War II, the German Enigma machine needed to be cracked. And since then, we now work and live more in our world, where we're dealing with devices and wearables and something called IoT, Internet of Things, and IoMT, Internet of Medical Things. So the reason that that's important is when we take everything and we hang it off of a network, every single thing that we hang off of a network is another access point, potential access point to that network. If we have incredibly valuable information here and we hang something off here, this thing is an access point to that data. The challenge with Internet of Things and hanging things off of these networks is that the smaller the object, the better, right? Well, the smaller the object, the less power we have to run real good security. So at best, we have some basic usernames and passwords to these devices that we, hook up to our houses, right? Our Ring doorbells and our refrigerators and our cars, and we all are connected to our own local Wi-Fi. Our own local Wi-Fi might be weakly connected, but on top of that, we're hanging devices off that really have basic username and password type, security. And what we're doing is we're taking this core valuable data that can make or break an organization or make or break a person, even more personally to us, so we can understand it better with identity theft and things like that. We have this really sensitive information, and we're purposely allowing outside access to this data, at least to the network that data is on. And we're not stopping either. We're actually asking for more. I want more things to be connected. I want everything to be connected. I want to be able to transfer money, right? If I could show you or explain to some of you what it was like before the internet to go and get money, it was difficult. You had to have a checking. You had to physically go to the bank, you had to wait online, you had to fill out forms, fill out slips. You had 2 or 3 people looking at it before they gave you money. It was hard. Now, boom, swipe, transfer money at a dinner table, split the bill, right? Send money through Venmo and all kinds of stuff. It's so easy to drain money from your account without you even knowing it. And you're asking for it. We're asking for it. We're saying, I want more of this. I want more online banking. I want more easily pay for things. I don't want to go through the Amazon process. I want to go pay. I want to go buy now and just buy it and have it show up my door. So we're demanding these things. And what it's doing is it's putting this unbelievable risk out there for people to kind of just get the right information from us through a variety of means and then use that information to kind of get stuff for themselves. Okay, so let's look at this from a history point of view, right? We had the ARPANET was a research network in 1969 with only 4 universities connected, a very basic network, a little bit dated. In 2018, we've got 11 billion devices, and we're on our way to 20 billion devices in 2022. So, in a year from now, we will have close to 20 billion devices connected to the network. That gives you 20 billion access points to any sensitive data that you might be storing on that network, okay? That's 20 billion potential attackers that might try to get your network in one way or the other. We might try and get your data. In addition to the amount of people that are out there, amount of data that's out there, the amount of connections that are out there, never before in IT kind of history have we seen a formalized, structured marketplace for stolen data. Okay, this is important. This is the equivalent of an automotive chop shop, right, where they go and steal cars and then they break up the pieces and they store them and people go and buy them. This is the equivalent of filming movies with video cams and then selling the CDs on the street, right? There's an organized marketplace that isn't really being monitored the same way that it should. And we call it the dark web. So the dark web is this place where the servers that are hosting data on the web are not indexable, so you can't really find them or search them through IP or a name. And it's very hard, almost impossible to trace them. So when somebody goes on the dark web and buys data or puts data up there to be sold, they're basically processing these transactions really quite secretly. And on top of that, most of the servers are kept in an international environment, so they can't really be prosecuted as far as the way they're being hosted. So we have this enormous network of devices that provide access to the rest of the network, right? The access points. We have an incredible amount of people that are getting formally trained in computer science and IT, and many are choosing, right, one path or another from a moral perspective. We'll talk about that in a second. They're choosing the dark side versus the light side. So you have these skilled labor force entering the cyber workforce. So you get the bad guys, right? And then we have this formal marketplace, right, for data. So we have these bad guys getting more and more skilled in acquiring data. We have a marketplace that's actually a place that's fairly safe to sell data. And we have, more and more data out there than ever before, and more ways to get the data from ever before. So it's this perfect storm of evil that's just growing and growing and growing. And we don't have enough people that are kind of becoming the cyber cops on the government side or on the industry side that are looking to really kind of solve this problem and contribute to catching the bad guys. Okay, so these are a little bit dated, but they're good to point out certain points here. There's an enormous amount of money being lost. They estimated somewhere between 500 billion and $1 trillion now, but if you think about that per year, that is the cost of data that's being stolen, systems that need to be repaired, loss of projected revenues, such as losing trade secrets and things like that, or patents that might be something new that you design. So it's really a calculation of everything that people are calculating is being lost in a year's time. There's a few interesting pieces here, such as the amount of time it takes for a company to recover from a breach. And if you look at the insider attacks that happen from people that work for you, right, they're about 50 days, while ransomware attacks, companies from the outside, organizations from the outside that basically encrypt your data until you give them money and then they decrypt it for you, is about 23 days. So this enormous amount of time that you're not able to do business in between before you get really back up to normal, that's a big chunk. You're losing money in that time frame, and then you're paying people to fix the problem in that time frame. One single event, one single breach can cost, gazillions of dollars. And we also have to take into consideration the public company perspective. So if you're a publicly traded company, you have a stock value. Once that breach is made public, which is a mandatory legal requirement to make the breach public, you now have a drop in stock price, which then affects the overall wealth of the company, which is enormous. So it's a really big deal. Again, this is why companies and organizations are forming these teams, these security-focused teams, to try to govern and control some of this risk and reduce some of this risk and control some of this risk that they have based on just because they're storing valuable data. So here's a few of the pieces that are, kind of up for discussion as far as jobs that are available. We saw really at any given time between 200 and now really about 400,000 jobs, somewhere in there, on a regular basis. The average starting salary is about $90,000 a year, which is about 30% higher than really computer science and information security systems, which are still quite high for new grads. Right? We see the NSA and industry looking at two different numbers there, but basically, if we look at the 1 to 2 million job shortfall by 2022, that means we have, when I say shortfall, I'm saying that there's too many jobs for the amount of people that are going into the field. Okay, and that's still open for discussion, today as far as where those numbers lie. But there's a chunk of jobs that are available for people that can actually demonstrate their hands-on and working knowledge of the area. Basically, what it says, what this is saying for you, is that even if every student in computer science in the country, in the world, decided to go into cyber specifically, which they don't, they want to be web designers and software designers and all kinds of stuff. Even if we took all of those, we'd still have this enormous shortfall. So there's no solving the problem anytime soon, which is a benefit to anybody looking to get into cyber as a career at any given level. What are those levels? What we do is we as a college look at these different organizations. We're part of the CAE community, which is the Center of Academic Excellence for Cyber Defense Education. And we provide these different particular courses that are part of your computer science degree, but also part of your cyber degree, right? So you take getting a degree in computer science with a concentration in network security, or you're getting a graduate degree in cybersecurity. One of the things that we highly recommend is that you also get the professional certificates because they're recognized. So there's three things that are recognized. One is that you have a college degree. Two is that you have a degree in a technical field. And three is that you have professional certifications. So they see that you went to college, they see that you went to New York Tech and that you were a cyber graduate. And then also they see that you've got professional certs, which are what they recognize, right? There's a bunch of different schools over a bunch of different programs. They may not recognize this, but if you get the industry certs, they understand that those are what they value on top of your education because they understand those. So what are those certs? CompTIA offers a couple of different very popular certs: Network Plus, A Plus, and Security Plus. A Plus is not cyber. A Plus is just that you understand how a computer works and how a network works. Network Plus shows that you understand how networks work and how the OSI model works and how everything kind of communicates with each other, which is where cyber really lies. And then Security Plus is where the degree that will show that you understand all the different ways to secure users and systems and networks and appliances on your network and things. Those three degrees, those three certs, highly recommended by us for you to go after as far as professional certs, especially in security, because they're going to want to see that you can understand all three of them. IEC Squared is the leader for information security, like leadership and management and upper management. So any of these certs will show that you have an unbelievably broad experience and exposure to all the different 8 domains, we call them. We call them 8 domains of different knowledge base. They range from legal frameworks, they range from design frameworks to encryption to actual applications. So they range all these different areas, but it's a big, broad understanding of the area. And ISACA, which is controls and auditing. So I do recommend that you look into these, even if it doesn't seem like it's as attractive as you might think of where you want to be in cyber. But keep in mind, every organization that is under some sort of a federal or state or even a local requirement to protect data, or even international, if it's European Union, if you're dealing with European Union customers, these particular certs will qualify you as an auditor to make sure that those companies are meeting those requirements, so they either get fined or don't get fined or whatever it might be. So, again, there's even jobs to be an auditor to make sure that systems meet requirements that they're required to meet. So what are some of these job titles that we might see, or you might look for as you're looking for jobs, right? Security analyst, security engineer, right? So security analyst is going to look at all the different logs and different reports coming in. You're going to analyze, is this legitimate? Is this supposed to happen? Or is this out of the norm? If you're using different pieces of software on your system to report traffic, network traffic, and you see on a regular basis that Bob Smith's workstation on the second floor on Tuesday nights is always busy. It's always generating a lot of traffic. Well, Bob works Tuesday nights, so it's not a big deal. But if all of a sudden Bob works 9 to 5 and Bob's machine starts generating tons of traffic at 2 in the morning on Tuesdays, that's something to look at. An analyst looks at that, an analyst bumps it up to the engineer and says, listen, I think we got a problem on the second floor. Look at Bob's machine. I think you'll see something on there, and you look for the actual names of the EXEs that are running and things like that can cause this increase in traffic. Right? And the security engineer will then, right, if you're a security engineer, you'll then basically analyze the problem, fix the problem, get everything back up, report the problem, figure out who else has it, figure out how to solve it on a larger basis if the whole network has it. Security architect is a very high-level job. It's basically designing the network or redesigning a network a lot of times if it's been deemed that it's unsatisfactory as far as the requirements go. Security administrator, controlling who has access to what and when. Classifying data, basically saying that, this data is kind of top secret, confidential, or private, right? And giving access to the right people at the right time, or taking away access, right? Sometimes people get let go, and your job is to do that. So the administrative pieces for that. And then, security software developer, you can get a job with a company that like McAfee or like Microsoft or whatever, working in the software area where you're designing security software. But you're also going to be designing software for a company that software has to be deemed to be secure. 2 different concepts there. One is that you work for a company that designs security software, right? Designs software that keeps your system safe. The other is that you work for a software company that might make some sort of a phone app, whatever, but you're the security expert as far as the software goes, that you design that app to be safe. That app isn't running on, that app is encrypting data before it sends it out. That app isn't running on open ports that shouldn't be running on, and all kinds of things that you would do to that software to create that secure software piece. And cryptologists, if you heavy in the math area, but basically, if you look at some of the history of cryptography, which we won't do in this session, but essentially, if you look at some of the history of cryptography, where you look at the scrambling of plain text, goes all the way back to something called the Caesar shift cipher. The reason it's called the Caesar shift cipher is because it was used in Caesar's time by Caesar, right? So that's how far back it goes in encrypting information, making it so scrambled. But if you look back at that simple one that's easily crackable even by humans, and you look at what we use today with AES, with advanced encryption standards, the way we use math to basically create really difficult problems to solve, to decrypt information, the methods we use for that, the algorithms we call them, and the size of the keys we use to do that, to decrypt and encrypt, all those methods are always being created because somebody's going to crack it eventually. Somebody's going to break it with something sometime. So we have to be ready with the next one. Cryptographers and cryptanalysts look at those methods and make new ones. Then, of course, you have the Chief Information Security Officer, CISO, which is the leader of the organization as far as right up there with the CEO. That comes after years and years of experience. And of course, there's a security consultant, which you'll work for a company that specializes in securing companies if they don't have the wherewithal to do it themselves. One of the documents I highly encourage people to look at is something called the NICE Cybersecurity Workforce Framework. National Institute for Cybersecurity Education, the NICE organization, put together this with NIST, federal government's organization, and basically this identifies all the different kind of knowledge, skills, and abilities, they call them KSAs, that each job requires. So I always like to introduce students to this document because when you look at it and you say, oh, I think I would like to be in that area of cybersecurity, and I think I would like to do that job, let me see what I need to learn. If I don't know it, let me learn it. If I do know it, I can do that already. This is a pretty good one for me to go to because I can do 50% of the items already. I don't know the other 50%, so let me go and study them, right? I like it because it's a nice document to see what you really need to know on a hands-on basis to get those jobs. So take a look at it. You can just Google it, by the way. It just comes right up as a PDF, so it's out there. Okay, so just to finish up this section, there's a couple of things I usually do, like what we know, what we don't know. I'll just go over a couple of interesting ones, for right now. We'll go through all of them. But basically, we know we're moving towards 20 billion connected devices, which is clearly the reason for the increase in threats. We know that we're demanding more access to more data on a regular basis. We're the cause of it. We want more all the time, so we're demanding for these companies to open up more and more and make our lives easier. We know that there's a formalized market now in the dark web, right? So we know that there's a place to buy and sell this stuff. We know that we're formally training people now, which we haven't really done before. It used to be the hacker who would go off and learn this on their own, and they were the risk. They were also the benefit for a company that hired them. But now we're formally training people in this group. We don't really know long-term what that's going to mean. We're hoping that it fills this gap of the need. We're hoping it doesn't cause other issues down the road. So, and we know that if we don't address this gap, this widening gap, eventually one's going to overtake the other, right? The bad guys are going to win, and it's just going to be a constant. There's going to be a reduction of services that we want and we need, and we want to keep moving forward. But there's going to be a reduction of services because banks and hospitals, they're just going to stop taking the risk. They're just not going to put themselves out there anymore. If they keep getting fined, they keep getting hacked, they keep getting broken into, they're just going to go back to a paper system because they don't have people to protect them, right? We don't want to go there either. Basically, that's kind of like what I wanted to try to cover in the first piece of this. And now we're going to go into the different tool sets that are available to cyber experts. Okay, so let's get into the second part of the seminar here, which is some tool sets some practical tool sets that we use in industry. So many of you are familiar with Linux as an operating system. We have like Ubuntu, and we have CentOS and things like that are distributions or flavors of Linux, right? So basically the Linux kernel is a publicly available open source kernel. And then we can, as a company, we can take that and make our own version of Linux. And that becomes our version of Linux. There is a company that created a version called Cali Linux, and they created it specifically for the cybersecurity professional, right? So it's called a pen testing software, which is a penetration testing software, or system, really, I should say. There's about 200 plus pieces of software in Cali that allow the cybersecurity professional and expert to do a bunch of things on the good side, right? So in other words, we want to basically test our network for potential flaws and potential vulnerabilities that may lead to a breach. And we want to fix them. We want a bunch of networking tools to see how our network is performing. Is it performing at peak performance? And if not, why? Are there things stopping that? Or are there things you want to watch out for? We have all these different tools and pieces of software we want to run to do that as a good, right, as the good guy. But as Cali Linux is a free distribution, it also is available to the bad guys, right? So the same tool that helps us protect our networks is the same tool the bad guys are using to find flaws and vulnerabilities in our networks. So it's this cat and mouse game, this kind of eater be eaten, hunter be hunted type mentality that's going on now in cyber. And I'm going to use this opportunity to specifically ask yourselves to look, kind of take a look at yourself, look in the mirror and say, is that the kind of life that I'm looking for? Is that what I want to do? If you don't, then it might not be for you. But if you do, if you like the idea of stopping somebody from getting their identity stolen and stopping them from, from having their life altered, sometimes irreparably. If you like the idea of catching the bad guy and then stopping somebody from doing harm, that's good. That's, it's not just tech. It's really about crime. So if you like that, then you're in the right, heading in the right path. It's this constant catch up and keep up, and I'm good today, but then tomorrow I'm not because somebody discovered something, right? So it's really something that you want to be dedicated to day in, day out. And tools like Cali allow you to do that. Okay, so let's go through a couple of basic things before we get into Cali specifically, just on networking and operating systems, some of the Cali tools, and how you can get started with Cali on your own. I will kind of start with a little bit of a precursor. Everything that we're about to talk about, if you do it anywhere but your own network that you own, you are breaking federal law. As an introduction to this and as a caveat to this is not something you do at Starbucks on their open network or McDonald's or even on the New York Tech network. This is something you set up your own network at home or your own computer system, and you do what we're going to be talking about on that. This is extremely clear in the law. It's extremely punishable, and it's something that is not taken lightly really anymore in any sense of the word. Just keep in mind that as we talk about these things, they're more for educational, instructional purposes. If you choose to do them on your own, that's our caveat where, we've told you not to do them on your own. So a little bit about networking background. We talked about binary before and sending bits, sending zeros and ones over the network, and that's really what the bad guys are looking for. There's a very physical process to this, right? When we connect from our laptop to our wireless connected to our router and so forth, it's going out, when you drive down the street next time, take a look at your telephone poles and all the wires going through. That's where this data is residing. You may be in your house and in your locked door in your office, but once you said send, that information is going over those publicly available lines that you see running, all through your neighborhood. At any given point across those lines or wirelessly, don't forget you're emitting wirelessly out from your house or your car, wherever you're sending it from. That's available all the time. So we have all different ways of capturing this data and analyzing this data. But keep in mind that data is being sent over extremely physical, like you wouldn't believe if you haven't been exposed to networking and how it works. It's an extremely physical piece. It's, we're sending electrical impulses, low voltage and high voltage impulses as a 0 or 1. Low voltage is 0, high voltage is 1. We're sending them over wires, over copper, and we're receiving them on the other end. It's extremely base level as far as how we're sending signals. What we do with those signals in something called, well, we'll go over in a second, but basically what we do with those signals from the physical layer, it's called the OSI model, is what I was going to get into next. But basically when we send them from the physical layer all the way through the presentation layer, we're doing different things to those signals to make it more and more complicated so that we can exchange information between computers. But essentially the physical components of our networks are physical. They're really physical, wires and receivers and things like that. So this is what, we talk about cybersecurity and it's a sector. It's really all based on transmission of data. We have to send data between machines so that one operating system and another operating system can communicate between each other and can send data right back and forth, and one can read it and so forth. So we have this ability through these different layers, right? The physical layer being the actual copper cable that we talk about, or fiber glass cable that we talk about, all the way up through the application layer when we actually use the data inside of an application. At each level of data, we're adding more and more to it, specifically in this 3 layers here, between the data lake and the session layer. Every time we add in a piece of data on that, it's creating a frame that we send over in these different packets, and the packets split up and go all over the network, and they come back together, and the frame puts them back together, and we can then decipher it. But it's an incredibly complicated process but it works great. And it creates TCP/IP, Transmission Control Protocol / Internet Protocol, which is a standard language, which allows every different device, no matter who makes it, no matter what company makes it or who designs it, the hardware, the software, as soon as that data leaves, TCP/IP allows that data to be read by any other computer in the world. It's an amazing system. It's amazing. And that is what we're trying to protect, because that data is plain text unless it's encrypted. Okay. One of the things you should be extremely familiar with in cybersecurity, if you're going to consider going into it, is something called the McComber Cube. The McComber Cube breaks different pieces of things you have to consider whenever you're making a decision in cyber. Okay, really just in IT. So we have CIA, the CIA triad or triangle, we call it: confidentiality, integrity, and availability. The data has to be secure, has to be valid, and has to be available to people to use. Otherwise, otherwise it's useless. Why bother? But at the same time, the way we transmit, how are we maintaining integrity while we transmit, how are we maintaining availability while we have it in storage, right? So all these different things form this cube, and we have to consider, if we're going to put a new server in, we have to consider every part of this cube is to say, when we put the server in, are we making sure that our CIA is in place compared to all the other components? All right, so that's something you should be in there as well. Keep in mind, we have different operating systems. We have Windows, iOS, Android, Mac OS, Linux. We have all these different operating systems that operate on a different kernel, and we have to be able to secure data in all those different operating systems. Cali Linux is a Linux-based operating system, so we have these different components of the operating system. So as you install Cali and you work with Cali, keep in mind it's an operating system. So if you don't do it right or you do this on your own, you're going to wipe out your current operating system. Do not do this unless you're ready to do it on a machine that's available. This isn't a recommendation we're giving. It's more of you understanding that Cali Linux is an operating system. It's not just a piece of software. It's going to replace whatever operating system is on your system currently. And you can see kind of where these different Linux distributions lie. And what you'll see is that out of all these different Linux distributions, you won't see Cali. And the reason is that Cali is not an operating system that you would use to roll out to a high school lab or to a college lab or something like that. It's an operating system that's specifically designed for ethical hackers, for white hat hackers, for pen testers, right? So you don't want that to be extremely broadly implemented. You want it to be kind of something that is used for professionals. All right, so let me talk a little bit about Cali real quick. Cali is going to look very similar to any other operating system you've used, Ubuntu, as far as Linux goes. It's even got some similarities to Windows as far as some of the folders, and you know, don't be confused or mystified that it's some magical operating system. It's just an operating system like any other operating system, but the tools that it includes are all cyber focused. So, and they're all built in and they're all part of the operating system. So when you download these, all of these different categories that you'll see, password attacks, wireless attacks, reverse engineering, exploitation tools, sniffing and spoofing, these are built into the Cali operating system so that you can understand, so that you have tools to use to explore some of these options. Cali breaks their system into categories. So if you look at the different categories, this is a great learning tool for you too, to get an idea of what is expected from you in the field. If we look at information gathering, vulnerability analysis, wireless attack, web applications, you are going to be expected to be able to understand why there's these vulnerabilities on this network and why they're at risk. And then you're going to be able to be expected to use some of the tools to kind of get an idea of what might be happening on the network, what might lead you to the next step. You have to be kind of a detective to see, oh, there's a lot of things running on the network and there's a lot of things that are supposed to be running, so I'm not going to bother with those. But now I found one that shouldn't be running and I can't identify what it is, and it's named inappropriately. The size is so different from anything I know of. The amount of traffic it's producing, the amount of processor and memory it's using. There's all kinds of things that are characteristics of these malwares that are causing these issues, right? So there's different tools for you to identify these things on your network. Okay, and if you look at the Cali tool listing, it's just enormous. I mean, it's like 200 plus tools that each one, some are massive, some are simple, some are really simple tools that are just very, very focused on what they do, but some are massive. We've created a PDF of all those tools, but honestly, the best way to get those tools is just to go to the website and take a look at each one of them. They organize them very easily. So Cali is a free tool put together by a company. And basically, once you download it, you would select an image that you want to choose for whatever system you're operating. If you have a 64-bit system, a 32-bit system, whatever it might be, you're going to download that image. Once you install that, you can create it as a server-based implementation, a workstation-based implementation, or a USB-based implementation. If you take a USB drive and you create a bootable USB drive. We use Rufus in the lab at ETIC. Once you create a bootable USB drive, that as long as your machine is programmed in the BIOS to boot off of the USB, whatever operating system is on that USB, it'll use that operating system. So that's one way to do it, where you can keep your operating system on your local laptop safe, but you can also have this bootable piece on your hard drive. But essentially, you would basically download Cali as an image, as an operating system image, an ISO. Then you would create a bootable USB, and then you would, using a program like Rufus, you would just take that operating system file and make it part of that USB file. Now that USB, you can boot off it. And very common in the field, we use the USB to basically reboot a machine, but into Cali. We still have access to the hard drive of that machine and the network through the network card. Amazingly, the way they do it is just incredible. Basically, once you're booted up into that machine on the USB drive using Cali, you can access the network like that. So we'll end this section as a quick ethics and access discussion. There's 10 principles of ethical hacking, and you can kind of take a snapshot of this. I won't read it to you over here, but essentially, look, I will be honest, ethical, moral, and true to my word while using my technical skills, right? That's what we want from you. I will strive to have a positive attitude, to be civil at all times, right? We want you to basically say, I learned how to do things. I can do these things. I'm going to choose ethically to do them for good, right? That's really what the world is looking from you. If you have any evidence of using them in any other way, it's going to be incredibly difficult for you to move into this field, okay? So you want to be able to demonstrate to organizations when you go to the interview that you are indeed an ethical person, and that you have chosen cybersecurity for the betterment of mankind, and not the opposite, right? That's basically what you're looking to do. So take a look at these when you get a chance, and make sure that you're in line with these. Otherwise, I would highly recommend you choosing a different path. But essentially, right, we're doing this to, again, this is not just tech. This is not just tech. Cybersecurity is about crime, about people getting harmed. If you're not in this to stop that and to hinder that, again, think seriously about the career path. So I'm going to do a quick demo of one of the tools we use in cyber, and we'll see if we can kind of get this up for you. When two computers communicate, they communicate over TCP/IP, and they use that OSI model to basically take raw data, raw zeros and ones, and basically build them up into these frames that we send out, and then the packets go everywhere and come back in. And it's an amazing, beautiful solution, but it leaves a lot of room for people to listen in and to people to see what's going on, and to possibly even alter data. It's called man-in-the-middle attacks. They take the data and they pretend they alter it and then send it to you, pretending to be the person that you requested it from. So there's all kinds of things that can happen. One of the tools we use to look at all that traffic is called Wireshark. Wireshark is a sniffing tool and a packet analysis tool. And basically what we're able to do with Wireshark is we're able to capture, right, the actual traffic going over a network. So if we were to start this Wireshark session, these are all the packets that I'm sending. And we can see the protocol that's being used. We can see the IP address it's coming from. We can see the broadcast and the source it's coming from. In just a few seconds time, I can look at, anybody using Cali, using Wireshark as one of their tools, can look at traffic coming in from all these different areas, okay? And once we look at that traffic, we can start to note different things about that. We can see different parts about that traffic that will tell us what that message was, what was being sent, was it encrypted or not encrypted? Is there just an enormous amount of one type of traffic? You can start to put different filters on things. You can analyze different things. You can apply a filter to something, to one IP address. You can figure out that Bob Smith's machine on the second floor is generating a lot of traffic at 2 o'clock in the morning. Well, if you're suspect of that, you can set up a script in Wireshark to run at 2 o'clock in the morning and just capture Bob's traffic. And then you can look and say, I suspected that something was running on port 6270, and that 6270s really shouldn't be used at all, but, right, why is it being used, right? So, we have all these different ways we can be a little bit of a detective, and these tools help us to do that. We can use Wireshark to capture wireless traffic, right? We can see the network traffic off of our wireless networks. We can use traffic directly off of our wired networks, and we can basically capture all this traffic and then analyze it and start to decide, is there a problem or not? Which again, in the security analyst position, would bump it up to security engineer and say, Bob's machine needs to be reformatted. Bob's machine needs to get a patch applied from Windows. Bob's machine needs to get, a new security patch or something, whatever it might be, because we're identifying all this traffic that we see. Okay, so that was just a quick demonstration of one of the tools that we use, again, available in Cali, but there's, again, 200 plus tools that we use for different pieces, but that's a good idea to see what we do on a regular basis in industry. All right, so I'm going to stop the recording now.